So let's compare half up, which is a conventional type of rounding, with something that's called, another one that's available here is half even. So what it does, it behaves in such a way that when we want to do the rounding, now notice that we use zero scale, which means that we don't want any fractional numbers. Then, so this is the smallest scale that you can get. And so you should end up with the value, which is the whole part of the fractional number, because of this type of scale. And what it does, if it looks at the preceding number like 2 or 7 right here, and says, if the number is even, it will be rounding down. If the number is odd like this, it rounds up. And so 7.5 becomes 8, but 2.5 becomes 2. So this is the idea of alternate rounding, which is just depending on the numbers themselves. So it just ends up that the distribution of odds and evens somewhere in a large pack of amounts in some kind of financial batch of transactions would be pretty much balanced, and therefore rounding errors would be minimized. So the demo, let's take a look at the demo. I'll click this thing, and for simplicity, I'll just probably replace this code with what we have inside this main method in our sample to speed things up a little bit. This is a little longer program, so again the scanner needs some sort of import. Okay, so we have some imports right here, and I'll just jump back to the to a demo. So instead of running it, I'll just walk you through the code and we'll look at these examples. So let's walk through the code a little bit. So we create the scanner object and its references called SC. Then we set a string choice to yes, apparently. And in this big loop that controls the entire life cycle of our application, we say that as long as the choice is yes, apparently to continue, we say enter a floating point value. So we tell the user. And so there's some notes here which are interesting by themselves, but I'm going to skip over this. So to demonstrate the workings of it, I just say let's get next string from the scanner, and we parse double. So we get the string and we parse it as double. And of course we convert it to the double value. Then we create new BigDecimal and populate it also from the string value. Okay, so we get this from the user by using the scanner from the keyboard, and now we have the string, and we create this BigDecimal from a string. It's okay, just like you can parse double out of the string, BigDecimal does the same thing and populates its own value with the result of parsing it as double. The next thing that happens is that we set the scale. So we take this object, this is a BigDecimal, and we set the scale. And notice that instead of just doing this, because we're in progress of making our adjustments, of making our decisions, we so the first time we say half up, and then we say half even, and so we populate two more references, and sure enough, each set scale uses its own new operator internally and creates these two objects. So here, as a result, we have two of these objects. Okay, so one object is created as a result of this set scale. Another object is created somewhere here in memory. Two objects, both of them are BigDecimals. And there you see that when we enter right here this value 565, 2.565, okay, so then this is for a rounding half up. So here obvious, 5 is rounded up, so it becomes 2.57. So this thing will get 2.57. Okay, now with rounding half even, the things change, so that so this is the value that needs to be rounded, right? So this part, this 5 at the third position after the decimal point. Right before it we have 6. 6 is even, and therefore we're rounding down, because half even says even numbers are even digits like this 6 is a signal to round down. So this becomes 2.56, not the same as rounding half up. In the next example, we enter something like 575 after the decimal point. Again, we're rounding this, and so we need to be able to round. Half up simply says, oh, this is 5, so it becomes 5/8. So 7 becomes an 8. Half even says this digit right before the one that's about to be rounded is odd. It's a 7. And in this situation, it rounds up. So you see this the same thing, very similar examples, but that's the behavior. And so is this case as well. You just look at the number just before the digit that has to be rounded, and it'll tell you whether it needs to be rounded up or down in case if rounding is relying on half even. And that's what we do here. Just basically the rounding happens as a result of us saying set scale to decimal point after the fractional part and the rounding mode. Okay, so this is the rounding mode that we want. And so these are examples of conventional half up rounding and this banker's version of rounding that may rely on the digits themselves. Okay, so this is just another example. I'm not going to repeat this. You should get the idea. Normally, you don't just start programming these kinds of computations just from scratch and be done in a few minutes. You really need to have a strategy. You need to decide what should be your rounding mode. Are you going to use the BigDecimal class? How are you going to handle everything? What are possible dangerous situations that you want to avoid, and all of this. And then you start writing a little bit of code and you begin to test it. Just like, putting together a little program that allows you to test and retest what you have and give you some confidence about this logic. And then you make a decision that, okay, this is exactly what I will be doing in my production application, basically, in your project. And so this is how it works. But this is an interesting example of rounding with the BigDecimal. A very common mistake, like I told you before, is to just forget this, right? If you forget this, just like if you forget that BigDecimal doesn't change, you're losing a reference to a brand new object that set scale generates. You must remember to recapture your object references, because set scale and any other method that does any kind of manipulation updates in your BigDecimal objects will create a copy of that object. This is done for safety reasons in situations where financial computations are done on multiple threads, and it's just something to remember. It's a lot of classes are designed as immutable objects, but we just need to remember this. Yeah, so this is where we talk about this additions, multiplications, all other methods that modify the result, including set scale, which actually does the rounding. We must recapture the object reference. Okay. And there is also something to be careful with copying big decimals. It's not uncommon to generate some extra precision that you probably want to avoid internally, even when copying objects. So a very typical approach is that when you already have a big decimal named total, and now you want to make a copy of it and construct brand new big decimal, which is just a copy of it. So it's possible that you may want to do something like this. So a very common approach is to actually convert it to string and then use a string version of it to construct another big decimal. I'm not going to use example of it. You can experiment with this. Comparing big decimals. We talked about compare to method, and it works pretty well. There is also another method which returns -1 if the number is negative. So you can quickly check whether the number is negative, because you can no longer use, this is an object, so you cannot use greater than or less than 0. You really have to use some methods here, and the signum returns -1 or 0 if the amount is 0 here, or +1 if it's greater than 0. Just something else right here. Now you may also want to be able to format the outputs nicely. And of course, currency is a very typical thing that requires formatting. So perhaps you want to just do some conventional formatting. So this example shows you that there's another utility class which comes from the text Java library called number format. And this number format, the way things go is that you specify what kind of number format you want. So you can have one for currency, another one, for example, for percent, and percentages, right? And you can specify the locale. There are locales around the world. So if you're using a US locale, you'll be expecting maybe a $sign and insertion of commas between the 1,000 separators right here. So what you do then is that because the payment was already, we're pretending here that the payment is already computed and stored as a big decimal. So first you tell your payment, which is a big decimal, that you want to obtain a double value. So you get the plain vanilla double, and then you use this double to format it using the number format. It's called NF. And then so that gives you a string, and when you print the string, it'll be looking nice with all the decorations of the dollar amount as you would want. So just to quickly reiterate over this, just want to show you how many objects are constructed. Payment is an object, right? So payment here is an object, definitely. Then number format, get currency instance, returns an object. So this is number format. This is another object that we have somewhere in memory. Okay, so this is another object that we're constructing here. Payment double value. Double is not an object, is a primitive data type. So I suppose this is just a local variable somewhere in our code, right? So this is not an object. Number format, format. And we pass this double to the format method of apparently this object, and it returns back a string. String is an object, so we construct the third object, which is a string. Okay, so this is the original value contained inside this object. This is a helper object which is called number format, or utility class that does certain modifications to the string version of the value. And finally, string is something printable. So print line, we pass a string to a print line, and this string eventually is printed. So number format, when we construct this double, basically it takes this value double payment and processes it during this format and returns, essentially it takes this as an input right here and gives us an output in the form of a string. So 3 objects, as far as you can see, are being used in this little example.